In this video, we're building a basic Java test and running it on AWS Device Farm. No Appium experience is required. I'm using Visual Studio Code for this walkthrough, but no worries. Whichever editor you prefer is totally fine. The important part is getting that Maven POM file set up right. First, you'll need Microsoft's Java extension pack. We'll be using Apache's Maven archetype for a quick start on our Java project. Choose a group identifier and name for the project, then pick a folder to save your project files. Simply follow the prompts and open the folder to get your environment set up. We now have the app.java file open. It includes a main method, but since we won't be using it, I'll go ahead and delete everything inside. Our main focus will be on the apptest.java file. This is where we'll write the test steps. There's already one assertion there, but we'll remove it for now. Before we jump into writing the actual tests, let's take care of some dependencies in our pom.xml file. Now, in this demo, I'm covering how to run both JUnit and TestNG tests with Device Farm. So I'll need to add both of those frameworks as dependencies. On top of that, we'll also update the Maven compiler settings to use version 1.8. The editor has a feature where it can synchronize the class path configuration with the build file automatically. To enable this, I'm selecting Always here. JUnit is already configured as a dependency, but we need a few more to complete the setup. Let's navigate to the Maven repository and find the latest version of TestNG to add. I'll also update the JUnit dependency to the latest version available, which is 4.13.2. To interact with our mobile app, we'll need the Appium Java client. I'll find the code snippet on the Java client website and copy it over to our project file. To ensure we're working with the most recent features, let's head over to the Appium website and grab the latest version number. And there we have it. Version 9.2.2 is the way to go. Now that the build configuration appears complete, let's go back to the test file and begin crafting the actual test steps. We'll utilize an example code snippet provided by the Appium Java client website. The test steps themselves are quite straightforward and easily replicated. In essence, they involve locating an element and verifying the text displayed in that element. Let's ditch this line. It sets an ID for the device we test on, but that's not needed. When we run tests on our local computer, Appium picks a device automatically, and when we use AWS Device Farm, they handle all the capability settings for us. We'll now address the errors indicated by the red underlines. Clicking the Quick Fix link for the UI Automator error attempts to add the relevant import statement. Looks like the Quick Fix seems to have functioned as intended. The example code includes these test steps, but we won't be needing them, so I'm going to go ahead and remove them. Next, let's tackle the URL issue. Although the quick fix doesn't offer a solution, we can attempt to add the import ourselves. If memory serves, it's java.net URL. Notably, the URL method is deprecated, so we'll explore alternative solutions. Utilizing URI and subsequently converting it to a URL appears more suitable. Although the current syntax appears improved, it requires a throws declaration, which the quick fix link can automatically implement. We now need to define the path and file name for the mobile application serving as our test target. I'll guide you through downloading it. It's a bitbar sample app available on GitHub. To ensure compatibility with Appium version 1, we'll add WD Hub into the Appium server's URL path. Now, we enter the phase of crafting the actual test steps. Our initial action involves locating an element within the mobile application's first view. We'll then verify that the element's displayed text matches "Ask Mom for Help." Here's a quick glimpse of the first view's appearance. The assertion error requires attention. We simply need to add the import statement for the assertion class. While we're modifying imports, let's transition the framework from JUnit to TestNG, as we'll be demonstrating TestNG first. Our test environment and test are now prepared for a local test run to confirm functionality. Open another terminal window and launch the Android emulator alongside the Appium server. Remember to append WD Hub to the base path. I'm using a MacBook to make this video, but the commands in the tutorial are the same whether you're using Windows or Linux. The test executed without encountering errors, signifying a successful run. The next step entails creating a package compatible with AWS Device Farm. This web page is a valuable resource for locating information on packaging any test environment for AWS. It encompasses all supported languages. We'll incorporate additional lines into our POM file. These lines will construct the environment as a jar file and subsequently zip it alongside all required dependencies. We'll begin by adding a line that constructs a jar package. Following this, we need to copy two plugins, the Maven jar plugin and the Maven dependency plugin. final packaging step involves zipping. We'll create a zip.xml file. Fortunately, these configurations frequently function flawlessly when copied and pasted. After crafting the zip.xml file, we need to copy the Maven assembly plugin responsible for the zipping process. Here's a command that constructs the package. One final task remains before packaging. We need to remove the mobile app path from the test. Otherwise, AWS might encounter an error due to an inability to locate a non-existent file. AWS handles defining all capabilities, so it's best to avoid defining any within the test itself. Everything's set for packaging. We'll skip running the test because we removed the application path. Running the test would just give us errors. Packaging is complete. Let's verify the output. We have the two expected jar files, but the zip archive and dependency folder are missing. It appears we have a configuration issue. The plugins need to be located outside of the plugin management section. We'll make that adjustment and give packaging another shot. We now have a folder containing dependency jars, and a zip file containing the whole environment with dependencies. Everything appears in order, so we can proceed with uploading the package to AWS. If you're new to AWS, the most efficient approach to locate the device farm is by typing it directly into the search bar within the AWS interface. Let's proceed by creating a new project. Once we've created a new run, we'll upload the Bitbar mobile application that we'll be testing. As our test framework, we'll select Appium Java TestNG. Following this selection, we'll upload the previously created zip file. The next step involves reviewing the YAML file that will be utilized during test execution. While modifications to this file are not necessary at this time, I'd like to briefly show the line responsible for executing the tests. By default configuration, AWS Device Farm executes tests across 5 mobile devices. However, for the first test suite run, we utilize only one device, To achieve this, we'll create a dedicated device pool. When defining this pool, we'll specify that the platform equals Android. It's important to establish a maximum number of devices to prevent AWS from running tests across all available Android models. Without imposing a maximum device limitation, our newly created device pool would execute tests on a staggering 87 distinct Android models. I've accidentally done that a few times myself. While modifications to the device state are not required, we'll proceed with the default settings. Following this, we'll review the configured settings before confirming and initiating the test run. Once confirmed, we can then proceed to watch the test run in progress. The test execution was successful. Now, let's move forward to examining the generated test run video and logs. Customer artifacts can be downloaded by clicking the link. You'll find the appium.log file, along with an HTML report generated during the test run. Now that we've covered TestNG, let's jump over to JUnit. Now for the first step, we'll create a new test run. No need to re-upload bitbar, just grab it from recent uploads. You have to choose Appium Java JUnit as the framework. Then upload the zip file again. In this session, we'll need to tweak the YAML configuration a bit. By default, it's set up for JUnit 5, but we're going to switch it to JUnit 4. This involves simply commenting out a few lines pertaining to JUnit 5. Next, we'll specify our test class. You can find the test class name easily in your code editor. In my setup, it's listed as com.qa.mvanel.javafarm.apptest. That's all the setup we need here. Moving forward, we'll set up the device pool. We've previously set up a pool with one Android device. We'll stick with that configuration for simplicity. Finally, everything is set to run the test, but I won't click the confirm button because our test file includes a few lines specific to TestNG. If we were to modify these lines to match those in JUnit tests, then the test would run successfully. That concludes the tutorial. I showed you how to run Java tests in AWS with TestNG and JUnit test frameworks. Now it is time for you to replicate the tests and start taking the benefits that AWS gives us. Like I showed you, it is just a click of the button and AWS will run your whole test set with 87 Android models.